If we look at the picture of our home and the idea of bringing all devices connected together in the same connectivity requirements, which means allowing us to work from home, to entertain our children from home, and also beyond that, looking at the appliances and the future of IoT devices. This HomeGrid Forum brings together several industry players from the semiconductors point of view, from the operators point of view, system manufacturers and system integrators that are joining their forces for embedding a technology that is called GHN, which is an ITU-T standard for the deployment on any types of wires and any types of topologies. The mission of the HomeGrid Forum is to provide trouble-free and ubiquitous interoperability for consumers using the technology, regardless of the medium. Why I'm saying that? Because the technology has been standardized for working on power line, on phone line, on coax, on plastic optical fiber, in extension with Wi-Fi and also with Li-Fi, as I'll show you in some of these slides. The deployment is done through an intensive certification program that is meant to ensure interoperability at all levels, so that consumers and also operators can mix system vendors and different silicon vendors embedded in these systems with a peace of mind. Looking at the snapshot of the HomeGrid Forum, it is an industry alliance that started back in 2008, bringing together, as I said, an important range of providers, of technology providers, working over any wire. And it is important to take over from the content that is a globally recognized ITU-T standard. Originally has been intended to address needs of the telecom industries, those that are focused on providing home networking connectivity, that intends to extend the connectivity all the way to the gigabit and multi-gigabit. The industry that is looking at the quality of service and management features required to give us all this high bandwidth that we need, and now more than ever at homes. It is a proven technology that has been used for a broad range of applications, so beyond home networking, that is addressing broadband access, addressing electricity utility applications, industrial applications, as well as Li-Fi applications. What does it mean for the industry as such, for the deployment? Home networking is extending the connectivity inside the home from the set-top box, from the gateway, whatever the telco provider actually give the first access of the technology inside our homes. But then we need to extend that at every single room, at every single device of our choice. We need to provide connectivity everywhere inside our home and outside our home if we have also a small garden. That means for us home networking topologies. If we look at the broadband access topology, it is covering use cases when the fiber stops at the basement of the building or at the curb, what we call FTTB or FTTC. And then we want to capitalize on the extending on the existing wires of the infrastructure in order to take the connectivity further. That means without the need of making new halls, drilling new halls, of disturbing users, of disturbing homeowners, of getting approvals for entering into the house and extending that connectivity. So that for us means broadband access, because it's bringing the connectivity all over to the buildings or to the homeowners. And from that point onwards, it's hooking up with the home networking connectivity. When it comes to electricity utility applications, that means all the energy service providers that are undertaking a huge effort nowadays of installing what we call smart meters for uploading all the energy consumption data from our homes into the grid. And it's an effort that needs to be now real time. It's not anymore reading the data for once a month. Industrial applications, it is a similar topology, of course, as the name says, in industrial environment. And Li-Fi, it is an extension of the technology working in hand with Li-Fi, not just with Wi-Fi. And we can talk a little bit more about that later. All this is being done through an effort of mixing interoperable devices to extend to multi-gigabit speed connectivity, but mixing all these different vendors so that it's a peace of mind for all network service providers to maintain interoperability. The GHN technology embedded in a wide range of devices is covering home networking, as we said, and then all the other different connectivity and access aspects. This is a snapshot for you to take with you on addressing different profiles when it comes to certification. Going back to the topologies, what does it mean for us? As I said, the service provider gets the internet bandwidth connectivity at the door of our home, and then we have to take it from there and extend that. GHN does it in the most robust way with the GHN Wi-Fi extender. So it's the most robust wireless backbone. As by software allows this deployment in a smart way that the connectivity knows and the streaming knows at any time what is the best way of sending data, so that the coverage is fully ensured throughout the home. Independent of the medium, as I said, these different GHN Wi-Fi devices can have different sockets. It can have a power line socket, it can be a coax socket or a phone line socket, depending on the telco service provider and the topology of their choice. The delivery of 4K and then, of course, going beyond that, beyond 4K video, is done through deploying certified devices. Again, why certified devices? Because the certification of these devices ensure different testing is being made so that it is compliant with the standard, compliant with the specific threshold of performance, and compliant with the multi-source interoperability. This is the only way the coverage can be extended throughout the home in all the different areas. So you can connect a smart TV, you can connect a network storage device, you can connect your tablet, you can connect anything you have at home, any single appliance as well, as long as it is attached to a GHN connector. When we talk about broadband access in multi-dwelling units, again, when the fiber stops at the basement of the building or at the curb, in areas where FTTH is not made possible by whatever reason, because it needs specific permission to enter the building, if it's a historical building that has been protected so that no extra holes drilling is possible, then FTTH cannot be really fully installed to every single corner of the building. So these are specific cases when the fiber somehow will stop before reaching any corner of the building, what we call multi-dwelling unit, and like an MDU, like a multiple floor building. And then the fiber stops in some point of the network where it needs an extension. And the extension needs to be done and ensured through existing wires so that no more drilling is implied. That means power line, so electricity lines already in place. That can mean coaxial cables or phone line cables from the phone line service providers. GHN does this implementation of connectivity over any single wire. So when the fiber stops at the gateway, and then you have the headends that can have several GHN connectors serving multiple users inside the building, as many users as possible, so that using the existing wires, when the connectivity is extended through these multiple twisted pairs or coax pairs, that can get the connectivity all the way to any single floor, to any single apartment, or any single shop if it is a commercial building. That is the topology that has been put in place for the broadband access. When we talk about Li-Fi, what does it bring in addition? Until now, GHN has been deployed in conjunction with Wi-Fi, so that all these GHN Wi-Fi devices, and we are including towards the end of my presentation some snapshots of these devices. They work on wired and wireless connectivity mix, as I said, so that the data communication, it is using the best stream at any time throughout the walls, regardless of the topology. And this has been done through Wi-Fi. There is a big range of GHN Wi-Fi devices available on the market. For some specific cases, we do this implementation for Li-Fi. And here I invite you to read the white papers that the HomeGrid Forum has published for very specific use cases, such as schools and hospitals, where there is this trend of somehow blocking the coverage precisely for not being hacked by outsiders. Then what has been a disadvantage, because it cannot go on the other side of the wall, actually it is converted through Li-Fi in an advantage for preserving the security of the communication. So this implementation through the ITU-T standard has been extended now to include Li-Fi. So we are converting every LED light bulb in an access point, and the connectivity is extended in these buildings where we need special protection, even governmental buildings, NASA buildings and so on, where you don't want any hacker to get any closer. That implementation, it is transformed into GHN for Li-Fi profile. Another use case for GHN implementation, it is for the smart grid that I mentioned earlier. Through the power line. So the transceivers of our power line are embedded in this infrastructure. It can be smart meters, smart gateways in the electric utility grid that is connected all these different topologies. It can be to the single family unit, it can be in the multi-dwelling units, pretty much like the broadband access topologies, but it's meant to embed a routing algorithm that is supporting large number of nodes. Why? For the same reason of ensuring real-time communication. As we all know, for many years, the electric utilities were reading the energy power consumption once a month or twice a month, and we're getting the bills based on that. Now it is the European Commission mandate, as we know, in all of these countries, to install and transition to smart meters. And the smart meters, their main feature and the key feature for ourselves as users is actually to be able to read this power consumption not once a month, not twice a month, but to also anticipate that and to be able to read it not just daily, like even every minute or a couple of minutes as we wish, so that we can anticipate the power consumptions at our homes. We can anticipate power outages. We can know, of course, the amount of money that we would need to pay when the bill comes. So that is being implemented in a very interactive way, which is why going forward, it's a very important profile for all of us, staying at home and working from home as well, which is an extending the power consumption that can be managed through the smart grid based on GHN algorithms. If we look at the roadmap itself, GHN, it is a technology that has been established and deployed ever since 2008 based on the ITU-T standard. So you can see an interesting evolution of the standard itself, the division of the ITU-T standards body. So how the industry has been progressing through the what we call different waves of this technology implementation. It started with a 1 gigabit half duplex, and then that was in conjunction with the Wi-Fi 11 AC implementations, and then it went into the half duplex for 2 gigabits per second, addressing up to 2 giga broadband connectivity in the multi-dwelling units, and it going now to extend to 10 gigabits for duplex. So that can embed 11 AX Wi-Fi extenders, and then for the broadband access, 10 gig. So the industry is preparing itself. The standard is available and has been gradually evolving into allowing all this very high powerful connectivity, very high power based on managing the consumption and based on managing the high throughput that we need in all these different applications, because now more than ever, staying at home and working from home and having to ensure that everybody, all members of the family can have access in the same time, depending on what they are doing. Somebody, cooking in the kitchen, somebody working in the office, children playing in their room and streaming Netflix. And it's like huge amount of data that needs to be supported by service providers, in the same time the appliances that come as such. So the standard evolution is ready to support that and all these different implementations. If we look at very quick snapshot at the standard itself again, how does that translate into the connectivity speeds? As it's something that speaks for us. So you can see at the power lines, and of course the power lines, it is the number one medium that has been implemented, and also in the same time the one that has had more use cases being addressed, because it's a noisy medium. So the MAC rate is up to 1 giga, and then you see how the twisted pair is supporting MAC rate up to 1.7 giga, same on coax cables. So it is an implementation that has attracted lots of service providers for ensuring these highest performance types of connectivity for their subscribers. In the same time, it has one of the highest securities as well, because the connectivity goes in pairs. So every single node is able to communicate with every other node of the network by having a dedicated key, which protects the communication. It also comes with specific algorithms such as neighboring domains, interference mitigation, which are important for NDUs or tall buildings. In some countries, that is key, because you have very tall buildings with many different apartments in the same floor. In each apartment, so many different devices and tablets and smart TVs and so on. So that means a crowded spectrum, and it is important to use this neighboring domain interference mitigation algorithms that isolates every different cell, every different network cell to a unique key, so that no interference is allowed. So it's a standard solution that provides a flexibility for the topology at the highest performance, and this is all done through a strict certification program. A snapshot of the international market adoption of GHN technology. So looking at the different service providers that have been deploying GHN technology for all these years. Some of them are using power line mode of GHN, some of them are using coax profile or phone line profile. It really depends of the choice, of the selection of the infrastructure that was best installed or widely installed in a specific country. So then GHN being so ubiquitous, implementing the different profiles can be used in a versatile mode for any of these topologies. If we look at the retail availability, because that is important, when we have service providers deploying, in some countries, they give a pair of GHN devices. They were always work in pairs. You attach one to the set-top box to the gateway, and then you attach one to the, in the room of your choice, to the connectivity device of your choice, where you need it to the smart TV, whether you need to watch a TV, to the computer, whether you need to work, attaching in the same room with the tablet, whether you need to use a tablet, and so on for the IoT devices. So they do work in pairs, and you have one at the main gateway. But what happens if you want to go and buy for yourself? So when there is a retail availability, these are just snapshots as it happens. I'm in Spain now due to the lockdown. These are snapshots of the searches on Amazon, as you see, delivered to Spain. So I invite you all to have a look at your Amazon access and then try GHN delivering to different parts of the world so that you can see different designs, different profiles, different branders. These are just pure intersections of the search in Spain. This is one of the members, Contrand, and these are from another member, Devolo, which have been deploying in many countries GHN and Wi-Fi adapters. So just I invite you to have a look at the extended range of that availability. What is important to always check on these devices, and this is mandated by service providers when they do deploy this technology, it is to check the certification of the HomeGrid forum, which is done by third parties labs that are making sure it includes a full set of compliance tests, and it looks at all the different performance, as I said, sometimes point-to-point tests and sometimes point-to-multipoint. It is connected on the throughput and noise-free setups. It looks at the neighboring domain interference mitigation when you have so many different devices. It does pairing so that you can connect yourself and ensure security and so on. So all these different testing suites are available through the product logo test specification that says GHN certified by HomeGrid Forum, so that you can have access to highest throughput topology, highest throughput connectivity ensured by the topology and the standard itself. And this is the website as a reference where you can check details of the members, of the implementations, of the availability, certification, and other resources that explain how the topology works in all these use cases that I mentioned. And I have reached the end of my presentation. Many thanks for listening.